Hi sir, I'm Aman. Today I'm here on technical Team Radeon.
Hi, I'm Vikas. I'm the design engineer and manufacturing engineer of the car, and I'm head of technical.
So would you like to tell us a little bit about your role before we begin?
Sure. My name is Shashank Sahai, and I'm working over here as a R&D head for the mechanical department. So I'm working over here from last 10 years, and I have total experience of 18 years in the industry.
Oh, that's great. So we're going to talk to you a little bit about our car today and how we can make our car even better, how we can manufacture it in a way that is sustainable, that is innovative, and something that can push our team further ahead than others.
So for our first question, we wanted to ask, how does the aerodynamics differ for a car that's designed for a straight line compared to a car that's designed for cornering?
See, when we talk about aerodynamics, certainly we are talking about the fluid flow through the outer body of the car, right? Now, when we are going in a straight direction, the air which is actually opposing, you can say it is trying to decrease the speed of the car, is in just in the one direction, unidirectional. But once you are trying to turn the car in different directions, then there will be multiple forces acting from the outside of the car against the motion of the car. It will try to decrease the speed of the car. That will be in multiple angles, so the things becomes complicated.
Understood. That makes sense. So there's less downforce in a car going in a straight line than there is in the one that's in a curved line. Understood. Okay. So one thing about manufacturing, how can we reduce the overall mass of a car without sacrificing structural strength or durability during the race? Because obviously we experience really strong forces when we race. The car is really small and it's such a light car. How do we reduce the mass even more so we can increase speed further?
See, for that, first thing what you can consider is the material what you are using. Okay. Now I'll tell you one example wherein not initially, till date, even people are making engine bodies with aluminium, because aluminium is considered to be the toughest metal and the weight is the least one. Some time back, I discovered that one of the company, they are making the engine block with an alloy of iron, and somehow they have designed that alloy in such a way that it is stronger than aluminium and lighter than aluminium at the same time. So the material is the first thing what you have to consider while making any part if you are actually trying to reduce the weight. Thereafter, there are multiple things what you can do wherein you can actually consider the structural integrity as one factor, because what happens is once people are going for structural analysis of the product, they find that for maintaining or just for distributing the stress or just for increasing the section modulus of the geometry, they are actually adding some additional parts to give the strength, to just disseminate the stresses concentrated at one particular point. So that ultimately adds to the weight. So rather than doing that, you can actually think of giving some shape in the base material itself. Like suppose there is you might have seen some cars which have some kind of embossing on the roof of the car. If you have noticed ever that some cars have a plain roof, right, and some cars have some kind of grooves, you can say. In the automotive world, we call it embossing. Okay, right. So that's the operation wherein we just press from certain area of that particular sheet and just we try to bulge out that particular region from in the opposite direction. So what happens is, because of that grooves, the strength of that material increases that region. So you don't have to add additional material over there, but you are increasing the strength of that material. So that ultimately helps you to reduce the weight and increase the strength at the same time.
Okay, so we can incorporate that in our car.
Yes. That's kind of feature on the geometry you can actually look for.
For example, will that affect the aerodynamics or
that you have to see at the same time?
Right.
Yeah, you have to check.
Right.
And according to aerodynamics behavior, you have to design that particular size, the shape.
So we can implement some cars in the parts of the car which aren't affected by air. So like, for example, maybe the underbody, we can add a few grooves, and that could make a car more strong, more durable.
Certainly, but again, it should not add weight to the car, because your ultimate goal is to reduce the weight.
Okay.
Yeah.
Okay, let's move on to the next question. So, what is the ideal mass distribution for small scale car? Because for larger cars, we when the car's cornering and when the car's being straight, you were saying about how like the aerodynamics is shaped, right? But like, how should we distribute the mass on a car that's going straight?
But it will be unidirectional. It will go only straight. That's what you're saying.
Right.
And you want to reduce the weight.
No, we want to know how we can distribute the mass on our car. Should it be towards the front? Should it be towards the back of the car? Should it be towards the side?
I think it should be uniform.
Okay, so same throughout.
Yeah, if possible. Although it's a bit difficult because certain components have their fixed position. Like the steering will be at the right side front only, right?
Yeah.
And other components also have some fixed position. But more or less, we should try to create a uniform weight because it is a unidirectional vehicle and it will move only in one direction. So if the weight is more or less same all around, that will actually help for a straight motion as well.
Okay.
Right.
But there are certain components in the car, like the CO2 canister, which add a lot of weight because of their high densities.
Mhm.
So how do we work around that? Should we make the front of the car more heavy to compensate for that? Or
Yeah, if for balancing you need to do that, you have to do. Similar to tractors, if you have seen, you might have noticed in the tractors, there is some load additionally added on the front of the tractor. Have you ever seen that?
Yeah, to compensate for the real wheels, right?
Yeah. Not only for the rear wheels, but there is some additional weight of the trolley as well.
Right.
And in India, it's a common trend that tractor owners are overloading the trolley. So it may not jump up from the front side. They add additional weight. Yeah, especially the plates, metal plates, which are being added on the front bumper of the tractor.
okay,
If you get a chance, just see, find it.
Right. Now, let's talk about the physical design of the car. So, what design considerations should we have to prevent aerodynamic faults from vibrating or failing at high speeds? For example, last year, we had a problem with that tether guide, thing that passes through the string. So, that broke mid-race and caused the car to fall off the track at a high speed. So, how can we avoid that while still keeping everything constant?
See, if you're not adding the weight and you're keeping weight constant throughout, I don't think it will happen. But the failure what you're reporting, I can understand that completely.
So when I was going at high speed, the thickness of the tether, it was too thin.
Okay.
So the tether got penetrated and just got cracked.
Okay.
Right.
All right. So for that, again, as I said, you have to consider material grade and thickness for this.
Right.
Because unless you have the right material grade and the right thickness of material, you will not be able to make a good design. Because material grade actually tells you about the density. Now density defines the weight of the geometry for every component, whatever it is, not only for cars, right? So with the right material grade and with right material thickness, you can only design the right part. Right.
okay, thank you, sir. Thank you. It's been very great. Thank you for all your insight.